Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. This week in astronomy, dark matter clues, star versus black hole, and Roman telescope's cosmic quest. Cosmic clues in the hunt for dark matter. Scientists at the University of Copenhagen are trying a very unusual way to look for a mysterious particle called the axion. This particle has been discussed for decades but never actually found, and it could be the missing piece that explains dark matter, the invisible material that makes up most of the universe. To search for it, the researchers didn't use a laboratory machine like the giant accelerator at CERN. Instead, they used nature itself, focusing on the largest magnetic fields that exist in galaxy clusters and the powerful light that comes from distant black holes. Galaxy clusters are enormous, so heavy that they outweigh the Sun by a quadrillion times. The axion, if it exists, is the complete opposite, so light that it is much lighter than even the smallest atom. Because axions could sometimes transform out of normal light when passing through huge cosmic magnetic fields, the researchers looked at radiation coming from bright galaxies whose centers are powered by supermassive black holes. As the radiation traveled through the magnetic fields of galaxy clusters, some of it might have changed into axions, leaving behind tiny irregularities in the signal. The problem is that each irregularity is so faint it looks like random background noise. The clever trick was to not rely on just one black hole. Instead, the team observed 32 supermassive black holes that happened to sit behind galaxy clusters and then combined all the data. When they added the signals together, a strange pattern began to appear. It was not the definite proof of an axion, but it looked like the kind of signature scientists would expect if axions were really there. What once looked like meaningless noise began to resemble a clear step-like shape, something the researchers describe as a faint cosmic whisper that has finally become loud enough to notice. This is still not a discovery, but it is a big step forward. By using this method, the team has been able to rule out whole regions where axions cannot be, which helps narrow down where to search next. Their experiment worked with gamma rays, but it can be repeated with other types of radiation such as X-rays, which opens many new opportunities for testing. The most exciting part is that this technique is not limited to one experiment or one research group. It can be used again and again, across many energies and situations, gradually filling in the puzzle of what dark matter might actually be. Star explodes while being swallowed by black hole. Astronomers have found evidence of one of the strangest explosions ever seen in space. They think it happened when a massive star was in a deadly dance with a black hole. As the star and the black hole orbited each other, they slowly got closer. The star eventually became so stressed by the black hole's pull that it exploded. This strange blast, named SN 2023 ZKD, might be the first time scientists have caught a star exploding while being swallowed by a black hole. The explosion was first spotted in July 2023 thanks to an artificial intelligence system that scans the sky for unusual events. Because the system caught it early, astronomers were able to quickly point many telescopes toward it, both on Earth and in space. That gave them a detailed record of what happened. At first, the explosion looked like an ordinary supernova, a bright burst of light when a massive star dies. But then something unusual happened. After fading, the explosion suddenly became bright again. When researchers looked back at old data, they realized the system had been getting slowly brighter for more than 4 years before the final blast. That long, strange buildup hinted that the star had been under intense pressure for a long time, probably because of the black hole pulling on it. The detailed data showed that the star had been shedding material before it exploded. When the blast finally happened, the first flash came from the explosion hitting thinner gas around it. The second, later burst of light came from the blast colliding with a thicker disk of material nearby. This messy and unusual behavior strongly suggests that the black hole was influencing the star in the years before its death. Another possible explanation is that the black hole tore the star apart completely before it could explode on its own. In that case, the debris from the star would have slammed into surrounding gas and caused the light astronomers saw. Either way, the end result was a bigger black hole left behind. This event happened about 730 million light-years away from Earth, but it gives scientists a closer look at what might be a whole class of rare explosions that we have never understood until now. It also shows how powerful AI has become as a tool for astronomy, since it can catch strange cosmic events early, before they fade. With new telescopes like the Vera C. Rubin Observatory soon surveying the sky every few nights, astronomers expect to find many more explosions like this and begin connecting the dots between how massive stars live and how they die when black holes are involved. This discovery was made by the Young Supernova Experiment, a project that uses powerful telescopes to catch new explosions as soon as they happen, giving astronomers the best chance to understand the most unusual and rare events in the universe. Roman telescope will uncover the changing universe. Long ago, people thought the sky never really changed, except for a few bright points that seemed to wander, which we now know are planets. As telescopes and detectors got better, astronomers learned that the universe is full of things that change over time, like stars exploding or black holes feeding on matter. NASA is preparing a new telescope, the Nancy Grace Roman Space Telescope, that will find a huge number of these changing events when it launches, planned no later than 2027. The Roman telescope will be especially powerful because of how wide an area of the sky it can capture in sharp detail at once. Its main camera will see a region 200 times larger than Hubble's infrared camera but with the same clarity. Over its first 5 years, Roman will spend most of its time on 3 big projects chosen by the scientific community. One of these projects will look specifically for things that brighten, fade, or explode, like supernovae and collisions of dense stars. This part of the mission is called the High Latitude Time Domain Survey. It will focus on regions of the sky away from the main plane of our galaxy, where things are easier to see. Its main purpose is to discover tens of thousands of Type Ia supernovae. These are a special kind of exploding star that always reach about the same brightness at their peak. Because their true brightness is known, scientists can compare it with how dim they look from Earth to figure out how far away they are. Roman will also measure how fast they are moving away from us. Putting those pieces together will let scientists track how the universe has expanded at different times in its history. This is especially important because of dark energy, the mysterious force that is speeding up the expansion of the universe. Some recent studies suggest dark energy might even be changing over time. Roman's data will be crucial for testing this. The telescope will be able to see the faintest and most distant supernovae, looking back as far as 11 billion years, which is only a few billion years after the Big Bang. That would more than double the timeline of expansion measurements we currently have. To find changing events, Roman will return to the same regions of the sky repeatedly, taking pictures at different times. By subtracting old images from new ones, astronomers can remove all the stars and galaxies that don't change, leaving only the new events. Most of this work will happen in the middle of the mission, when the telescope will scan the same spots every 5 days for about 2 years. Some fields will also be checked less often over longer times, to catch very distant events that evolve more slowly because of the stretching of time caused by cosmic expansion. This survey will also help find extremely rare explosions, like stars completely destroyed by black holes or parent-stability supernovae, which are massive blasts that leave no remnant behind. To catch both frequent and rare events, the survey will be divided into a wide part, covering more area and finding more common events, and a deep part, focusing on a smaller area to catch fainter and older events from up to 10 billion years ago. The survey will observe both the northern and southern skies, with follow-up observations from ground-based telescopes like Subaru. Roman will also collect spectroscopy in the southern sky, which helps confirm what kind of supernova or transient event is being studied. Altogether, this program, along with Roman's other large surveys, will give astronomers a new and detailed map of how the universe changes, going deeper in time and space than ever before. It will open the door to discovering countless unusual cosmic events and give scientists a clearer picture of how stars live, die, and shape the universe.